It's a pleasure to be here. And today I want to talk a little bit about neural insights for dazzling teaching in this new era of generative AI. So it's a very exciting new era. And I would like to refer to the words of Fei Li, the preeminent AI researcher, who says AI will not replace humans, but humans who use AI will replace humans that don't. So what this means is there's a wave of generative AI information that's coming out, and we need to take advantage of it, whether we like it or not. So I'd like to dive right in and say, what does Chat GPT do and other similar large language models? If we look, um, it's what these generative models do is they often are trained to predict the next word in a sentence. That's how generative AI was formulated initially, but there was a problem, and that is when the computer or when the generative engine, so to speak, was focusing on a sentence. By the time it got to the end of the sentence, what happened was it often didn't understand what was going on at the beginning. So there's a relationship between words in a sentence. And generative AI has figured out how to relate words in a sentence in a way that the older versions of AI could not. Those versions, when we put in a sentence to be translated, for example, about 5 years ago, you would have noticed that translations were terrible. And the reason they were terrible was that by the time the engine was focusing on the end of a sentence, it would forget what was at the end, at the beginning of the sentence. So what's happened now is there's been a new way of allowing these generative engines to focus on sentences, and not only whole sentences, but entire documents, and also the web as a whole, to be able to connect and see how words connect together. And this is what allows us to begin using generative AI, the magic. And the real magic behind generative AI is the transformer. And the transformer was first introduced in a paper that was published in 2017. It was in the Neural Information Processing Systems Conference of that year. And at the time, nobody really paid much attention to this paper. But since that time, this paper has been cited well over 100,000 times. And it's because of its introduction of that idea of the transformer. And what transformers do, and don't worry, I'm not going to go in depth into them, is they encode our prompt, what we're asking generative AI to do, and then it puts out the response. And I won't, again, go into the details, but if you look at this positional encoding, that's part of the brilliant magic that helps make transformers into numbers that we can use to relate words and in the form of word vectors with one another. So what's fun about this kind of thing is that even this paper, for example, you can see that this paper has actually been transformed into a song about transformers. And it's kind of fun to listen to. It's called Attention is All You Need. And it's a proposed simple new network architecture, kind of a catchy tune, actually. So if you go to suno.com, you can have a little bit of fun making songs about whatever you like. But ultimately, what we're really interested in here as educators is the idea that the flow of information through those transformers that are at the heart of generative AI is really quite similar to the flow of information through the brain. So this means that if we understand a little bit about how the brain processes information, we can actually get some more insight into how to effectively use generative AI. So what's going on in the brain? Well, we know it's very complicated, but if we focus in on a fundamental building block, which is just the neuron, we can see that that neuron, which has some legs and some little toes springing out of those legs and an arm that reaches upwards, what these neurons do is they send signals to one another. So here we see a neuron sending a signal that jumps the gap called the synapse and travels on to the next neuron. And what these neurons are doing is essentially, as you are learning something new, they are making connections between neurons in long-term memory. So whether you're learning a dance step or how to conjugate a verb or how to take a derivative in math, you're simply making connections between neurons in long-term memory. So how do you strengthen those connections? Well, practice. Practice helps to build those neural connections. And ultimately, though, if you kind of don't have time to practice, what can happen is your little synaptic janitor can sweep those neural connections away so you forget what you've learned. This is why practice over a number of days can be so important. Now, as you're learning then, what you're doing is you're creating nice, solid links in long-term memory, and those are easier for you to put to mind whenever you need that information. Now, let's step back a little bit and talk about Chat GPT. What is Chat GPT? It is what's called a foundational large language model, and I'll explain a little bit more about this in just a minute, that comes from the company OpenAI, which is pretty solidly connected with Microsoft. And the important point here is that it can be so expensive to create these large language models that sometimes it's good to go to the foundational models that are seeded or growing from or in affiliation with these larger companies, because these have more potential. They've got the money to be able to build really, really sound and comprehensive engines. So each of some of the major companies have foundational large language models affiliated with them. So Google, of course, has Gemini. This can take enormous amounts of input at once. Inputs are called tokens, but in essence, they're kind of like words, and you can feed almost 1 million words into Gemini. It's very, very large. And then there's Claude, which is one of my favorite engines. Then there's ChatGPT, of course, Grok, Pi from LinkedIn, and then Meta has Llama, which is an open source model. But there's many, many more foundational large language models that were released. As you can see, 149 of them were released in 2023. So it's pretty big. But what I want you to keep in mind is that, as is sometimes said, when you have a foundational large language model like Chat GPT or like Claude, they're like somewhat different engines in a car. And if you just learn to drive the car, well, it actually doesn't matter that much what the different engines are. You've still got the basic idea of how to drive a car. And that's what we need today, is to get a sense of how to get along with and drive that new car of large language models. So if we look, I want to kind of reveal to you that I was fooling you a little bit earlier. What I was doing, I said we form links in long-term memory to help us remember things. But what I didn't tell you was there's actually two pathways, two very different pathways we can use to form those differing links in long-term memory. The first pathway takes information from working memory, which I like to symbolize by this octopus. It's what we're consciously aware of, and it puts that information through the hippocampus into long-term memory. So don't worry, you don't need to know these terms. Just remember there's two pathways. And the second one is that automatic pathway of habit, which goes through the basal ganglia. This is the pathway you might use as you repeatedly drive home, maybe walk a certain route to get to your house, and you get used to it and you don't even think about it after a while. You can just do it habitually. Or tying your shoes, maybe even solving a Rubik's Cube. You can, and actually this basal ganglia automatic system is how you learn to speak your native language, which is why you can do it so automatically and quickly. And you need both types of links in order to be able to um, learn effectively and do things with what you've learned. So if we take a look, what does this have to do with large language models? It turns out that these two different systems can give us a better understanding of what is at the heart of large language models. So if you look at that blue box, the blue rectangle here, it symbolizes that hippocampal pathway. And this reddish box, it symbolizes that automatic basal ganglia pathway. And that basal ganglia pathway, as it turns out, is really akin in how it processes information to large language models and how they process information. So normally, when we're learning something, or let's say we're trying to figure out a problem, well, we're consciously aware of information that is flowing through the hippocampus. We are step by step consciously following and solving a problem. But this other way of looking at the world, we're not conscious of. And this way is in some fashion much more complex, even though we're not even aware of it. This way of processing information, and not to say that the hippocampus doesn't have a bit of this too, but this neural net, what it does is it's a huge web of interconnected neurons, takes information as you, for example, practice or do something repeatedly. For example, a math problem or practicing hitting a ball. Whatever you are learning, you'll practice it some, and each time you're practicing, you're learning, oh, that approach was not good, but this approach was better, and perhaps another approach was not as good. But you're gradually learning and you're training those neurons. Some of them are getting, the connections are getting stronger, others are getting weaker. And this is how your neural net of your automatic system is trained. it is very akin, again, to how large language model systems are trained. But what about this conscious hippocampal system? As it turns out, large language models really don't seem to have the equivalent of that. That's why we often need humans to look over and oversee what's going on, because just as in humans who have damage to their prefrontal cortex and their conscious thinking abilities, if you take out and don't have that hippocampal pathway, guess what? You make things up, you hallucinate, you confabulate. And this is part of why we must be somewhat wary of what's coming out of generative AI, because it can sometimes make things up. So when you're teaching, for example, you don't want to think of it as Chat GPT or one of the other models is your assistant. You can think of it that way, but you have to also remember that it's your assistant that's a little bit crazy sometimes. So just keep that in mind. Now, let's go back to what we talked about earlier with foundational large language models. And we talked about the biggest ones coming from some of the biggest companies. Of course, Apple is really coming up quickly with some interesting breakthroughs themselves. But if we look, there's software intermediaries that can go through some of these different models. And many of them now go through Chat GPT, because Chat GPT is the first out of the gate. So we have a number of writing assistants. So go and look up, for example, what Jenny can do. It's totally amazing. It can help you craft a report, a blog post, all sorts of different things. I think many people are aware of Grammarly, but Writesonic and Jasper similarly can give you some really good ways of more quickly writing material and give you insight into what research articles might be relevant. And speaking of research, there's lots and lots of different platforms out there available, or apps, so to speak, that can help you. And what's interesting is that these different intermediaries often are trained directly on research itself rather than just the web. So that means, for example, with Semantic Scholar, it's trained on 200 million different research papers. So it has a very different way of crafting and making available to you the results of its insights in this knowledge. Of course, there's straight live to internet, things like Copilot. Perplexity is very popular nowadays. There's also Magic School, which has many of these that I'm speaking about here, give you insights, for example, about how to easily construct lesson plans. And these can make the lives of teachers much easier. There's productivity platforms like Canva and Gamma, coding platforms, of course, like GitHub. And also we have imagery. So we've got DALL-E, that's coming from Chat GPT, and there's other platforms, other intermediaries like Midjourney, Stable Diffusion, Dream Studio. These are all coming separately, not from Chat GPT. And similarly, there are also video platforms that are really in the process of developing, but will soon be quite remarkable and already are in some of their capabilities. Now, some of the ideas here are from the book Teaching with AI, which is a wonderful book. And I'd also like to recommend the book Co-Intelligence by Ethan Mullock. So these give you practical insights into how to use generative AI. Good theoretical books are The Worlds I See by Fei-Fei Li. You heard from her at the very beginning. And also The Alignment Problem, which sounds like it might be a boring book, but actually gives you lots of insights into how generative AI learns different things. So in that perspective, I think The Alignment Problem is one of the best books on learning that I've read in years. So there's also wonderful courses out there. These are courses from Coursera, and that's, of course, one of my favorite platforms because my courses with Terry Sanowski and others are on the Coursera platform about learning and about how to teach effectively. But I highly recommend these courses. I just want to give you a little bit of insight into some of the capabilities you may already know, but just in case. Here's a picture of Greg Brockman, who's the co-founder and president of OpenAI. He just took a picture of a little notebook that he had. And on this notebook, he just annotated my joke website. And he put this picture onto Chat GPT, and lo and behold, it generated all of the code that was needed to be able to generate that website. But this also brings me to some of the differences between platforms, because I tried this. I uploaded this image to ChatGPT. It created this coding and more. But then I tried uploading it to Claude, which is one of my other favorites. And Claude said, I'm not going to make a joke website because you could put bad jokes on it. So I had to argue with Claude and say, well, wait, does this mean we have no more humor because it could, be harmful for people? And finally, Claude grudgingly agreed to create the code. So there's very much a difference between the platforms in how they're trained. And I just want to give you a little insight into this. So there's different model architectures. For example, ChatGPT is based on that GPT 4.0 model, whereas Meta or Facebook is based on Llama, and that's open. In other words, we pretty much know what the weighting of all those different millions and millions of of neural connections are, whereas ChatGPT, it's more it's invisible to us. We don't know what the weights are and how it's really trained. So the training data is often quite different. ChatGPT is trained on a massive internet data set, where Meta AI is trained on only a subset of the internet. Semantic Scholar, as I mentioned, is trained on research papers. So it gives each one a different feel. And each of these platforms or engines are tuned differently. Some of them are more conversational. Some of them are very matter of fact. Some take great care to make sure that the references are, insofar as possible, not hallucinated. Others don't care so much. And there's different personalities. So some are more formal, some are more friendly and approachable. It's a little bit different. So what does GPT stand for? Generative Pre-trained Transformer. It's that transformer that's the magic again. So just to give you a little sense, you probably know this already, but what is the difference between a search engine and using generative AI? When you're using a search engine, let's say that you're organizing a corporate conference. You have to go to the search engine, look for conference venues wherever you're going to be doing your conference, and you have to sift through information from catering services to guest speakers to event schedules to marketing and promotion. You have to ask it and then sift through the responses. Whereas using generative AI, it's more like, hey, what venue should I use? And it will provide a nice curated list of venues, catering services, guest speakers, event schedules. So you can ask it something, and it doesn't entail so much work on your part as far as really trying to understand how this particular event schedule, for example, is relevant to you. The biggest thing, though, is that with a search engine, you just put things in and it's a very much of a one-way communication. Whereas with generative AI, you can ask a question and then refine and ask it. It's more interactive. So that can make your life a lot easier. Now, one last little tidbit relates to memory and human memory. And so let's just talk about working memory, long-term memory, and octopuses. So as far as we're concerned here today, I think the easiest way to think of memory is that we've got a very temporary working memory. That's the memory where you hold things in mind by repeating them so you won't forget, hopefully. And then you have, and this is actually like an octopus in some sense, except maybe a quadrupus, because an octopus has 8 legs, but a quadrupus has only 4. And on average, we can only hold 4 things in our working memory. So we're trying to remember things as a speaker is speaking, for example, or we're trying to hold clumps of information, and we can usually hold only about 4 things maximum in those clumps of information. Long-term memory, on the other hand, is much more expansive. You can kind of think of it like a set of lockers. In those lockers, all over your brain are sets of neural links. So long-term memory is kind of hard for us to access. And but working memory, we're conscious of it. We hold it right in mind, but it's hard to keep it in mind. The interesting thing is, if you go and look at that working memory in humans, where we can only hold 4 pieces of information in mind, we have to work to put them into long-term memory. Generative AI can hold thousands, tens of thousands of pieces of information in its mind, so to speak, at one time, and make creative connections that can be very, very hard for humans to make, which is why it's sometimes generative AI is considered actually on tests to be more creative. So we want to work hand in hand with generative AI, use some of that creativity along with our own deliberative thinking processes to together create better schooling and education for our students and to make our lives easier as teachers. So I would say be part of the generative AI revolution and enjoy this new set of engines that are coming available for us.